Square root equations. We're going to solve three different square root equations. So example 1, the square root of x plus 1 plus 2 equals 4. Now our first step in solving square root equations is to isolate the radical. We want to get the square root by itself. And here we only have one square root, so we will isolate it. And we'll start by subtracting 2 from both sides. And now we'll have the square root of x plus 1 equals 2. Step 2, let's square both sides of the equation. So we'll square the left side and the right side. And when we square a square root, we're using inverse operations. And we'll be left with what is underneath the radical. So x plus 1 equals, and then 2 squared is 4. Okay, now we will solve for x. So to get x by itself, we'll subtract 1 from both sides, and x is 3. Let's get in the habit of checking our solutions. And when we check our solutions, we will always check our answers in the first original equation. So substituting in 3 for x, the square root of 3 plus 1 plus 2, does that equal 4? The square root of 4 plus 2, does that equal 4? 2 plus 2 does equal 4, so x equals 3 is our solution. Example 2. The square root of x minus 15 equals 3 minus the square root of x. Now, if there is more than one radical, like we have here, we can isolate either one. And we already have one isolated on the left, so we're going to leave that isolated and skip to the second step, which is squaring both sides of our equation. So on the left-hand side, when we square a square root, we're using inverse operations, so we'll be left with what's under the radical, x minus 15. But on the right-hand side, we are going to need to distribute. We're going to multiply 3 minus the square root of x times 3 minus the square root of x. 3 times 3 is 9. 3 times negative radical x is negative 3 radical x. Negative radical x times 3 is negative 3 radical x. And negative radical x times negative radical x is positive x. Let's combine like terms. X minus 15 equals 9 minus 6 radical x plus x. And we have a radical again. So we need to go through the steps again. We need to isolate this radical. So to isolate this, we will subtract 9 from both sides and get x minus 24 equals negative 6 radical x plus x. And then we'll subtract x from both sides. So negative 24 equals negative 6 radical x. We almost have the radical isolated, so let's now divide both sides by negative 6. And we get 4 equals the square root of x. Okay, now let's square both sides again. And we get 16 equals x. Let's check our solution. So again, substituting 16 in for x in our original equation. The square root of 16 minus 15, does that equal 3 minus the square root of 16? The square root of 1, does that equal 3 minus 4? 1 does not equal negative 1. So in this case, we have no solution, or the empty set. There is no solution to this equation. And x equals 16 is considered an extraneous solution. It's not an actual solution to our system. Remember, an extraneous solution is one that does not satisfy the original equation. Example 3. The square root of x plus 7 minus 5 equals x. So remember, our first step is to isolate the radical. We only have one radical this time, so we'll isolate it by adding 5 to both sides. So we have the square root of x plus 7 equals x plus 5. And now we will square both sides. And When we square the left-hand side, we get x plus 7. When we square the right-hand side, remember we need to distribute x plus 5 times x plus 5. X times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. Let's combine like terms. So x plus 7 equals x squared plus 10x plus 25. And we will solve for x. And we notice that we have an x squared term, so we have a quadratic equation. So let us get everything on one side, 0 on the other. And I'm going to move everything to the side where the x squared term is positive. So I'll subtract x from both sides, and I will subtract 7 from both sides. And we will get 0 equals x squared plus 9x plus 18. Now we could solve this with the quadratic formula, but this one will factor. So I'm going to set it up to factor. And we're looking for numbers that multiply to 18 and add to 9. And those would be 6 and 3. So this factors to x plus 6 times x plus 3. And now we'll use the zero product property and set each factor equal to 0. So x plus 6 equals 0, x plus 3 equals 0. Subtract 6 from both sides and get x is negative 6. Subtract 3 from both sides and we get x equals negative 3. So we have two potential solutions, negative 6 and negative 3. But remember, we need to check. So substituting first in x is negative 6 into our original equation. The square root of negative 6 plus 7 minus 5, does that equal negative 6? So the square root of 1 minus 5, does that equal negative 6? 1 minus 5, does that equal negative 6? Negative 4 does not equal negative 6. This is a false statement. So that means x equals negative 6 is not a solution. It's an extraneous solution. But it's not counted as a solution to our example here. Let's check x equals negative 3. So substituting negative 3 in for x in the original equation, the square root of negative 3 plus 7 minus 5, does that equal negative 3? The square root of 4 minus 5, does that equal negative 3? 2 minus 5, does that equal negative 3? Negative 3 does equal negative 3, and that's true. So x equals negative 3 is our only solution to this problem.